Hello, this is the study guide for Test 2. So let's go ahead and take a look at it. Alright, so problem number 1. What we have here is we have the universe consists of the elements 1, 2, 3, 4, and 5. Set A consists of 1, 2, and 3. Set B consists of 1, 3, and 5. And we want to list all the elements in A intersect B. So A intersect B are going to be the elements that are common to both A and B. And the elements that are common are going to be the 1 and the 3. So 1 and 3, those are the elements that are common to sets A and B. The next one is the union. The union is going to be the complete list of all the elements that are inside of set A, or inside of set B, or inside of both of them. So we want to list all those elements. So that's going to be 1, 2, 3, and 5. All right, number 3. Well, here we want to find a complement. That apostrophe means complement. So that means I want the stuff from the universe that are not inside of A. So the things in my universe that are not included in A are going to be the elements 4 and 5. For number 4, a complement union with B. So I need to find A complement first, which consists of 4 and 5, and I need B. So I want all the elements from B and all the elements from this one. So that's going to be 1, 3, 4, and 5. Number 5, well, here we want A complement intersected with B. Well, A complement, that was 4 and 5. The intersection, so I've got to look at B, and I've got to look at this, and I want the elements that are common to both. So when I do the intersection of these two, that's going to give us just the element 5. And we want the complement of that. So we want everything from the universe except for the 5. So that's going to be 1, 2, 3, and 4. All right, number 6, we want to use De Morgan's laws to rewrite this statement. So De Morgan's law says I can basically take this complement and distribute it through the parentheses. And when I do this, the intersection becomes a union. So the A complement gets a second complement, and then the B picks up a complement, and the intersection turns into a union. And then our double complement property basically means this is going to be A union with B complement. Number 7, find the number of items inside the intersection of S and T. So here we're going to use the inclusion-exclusion formula. The number of items in the union is equal to the number of items in the first set plus the number of items in the second set minus the number of items in the intersection. Alright, well, the number of items in the union happens to be 15. The number of items in the first set is 4. The number of items in the second set is 12. So we don't know the number of items in the intersection. 4 plus 12, that gives us a 16. So that leaves us with the following. That 15 is equal to 16 minus the number of items in the intersection. So that means the number of items in the intersection has to be 1. Number 8 works a lot like number 7. They tell us that the Choral Society and the Drama Club are holding a party, and of those, 80 people are attending. So the number of people that are part of either the Choral Society or the Drama Club, that happens to be 80. We have 65 that are members of the Choral Society, and we have 45 that are members of the Drama Club. So we're going to be setting up using the same formula. So we've got the number of items in the union, which is 80, is equal to the number of items in the first set, which is 65, plus the number of items in the second set, which is 45, minus the number of items inside of the intersection, inside of both groups. So this gives us a 110, and then 110 minus 80, that's going to be 30. So there are 30 people that are members of both of those groups. All right, number 9, we want to build a Venn diagram for the following. So a merchant surveyed 400 people, so the size of my universe is 400. I need to label my circles. I'm going to call this one Internet, this one television, and this one newspaper. All right, 30 people learned of the sale from all 3 sources. So 30 has to be inside of all 3 circles. 50 people learned from television and newspaper, so that means these 2 regions have to have a total of 50. 30 of them are here, which means 20 has to be here. 90 people learned about it from internet and newspaper, so I've got to have a total 90 here. 30 of them are here, so that means 60 have to be over here. 80 learned about it from the internet and television. 30 are here, so that means 50 are over here. 190 learned about it from newspapers. So inside my newspaper circle, I currently have 110. So 190 minus 110, that gives us 80. A total of 190 learned about it from television. This adds up to give us 100, so that leaves us 90 out here. 180 learned from the internet. So this right here, that's 140. So that gives us 40 out here. And then there is one other region, and that's the region out here. So let's add all these up and then subtract that from my 400. So 40 plus 60, that is 100. 80 plus 20, that's another 100. So that's 200. That's 280. Plus 90 gives us 370, and 400 minus 370 is 30. All right, number 10 uses the Venn diagram we built here. So how many people did not learn of the sale from any of the sources? That would be the region outside of all the circles, which would be 30. All right, number 11. A teacher makes a 5-question quiz. Looking at the test bank of questions, there are 8 choices for the first question. There are 7 choices for the next question. There are 12 choices for the next question. There are 5 choices for the next question and 3 choices for the last one. So if I multiply all those up, 8 times 7 times 12 times 5 times 3, that ends up giving us 10,080. Number 12, how many ways can a 9-member family arrange themselves for a picture? That is going to be 9 factorial, which is 362,880. How many ways can 3 out of 9 family members be arranged? Well, that's going to be 9 permutation 3. So 9 permutation 3. That ends up giving us 504. How many ways can 3 out of 9 family members be chosen, not arranged? That's going to be 9 combination 3. So 9 combination 3. 9 combination 3. Got to push the right buttons. That gives us 84. Alright, a family of 9 is saying goodbye to each other. If every family member hugs every other family member exactly once, how many hugs are there? So that's going to be 9 combination 2. We're trying to find out how many pairings there are, how many subsets of size 2. So 9 combination 2. That gives us 36. If a coin is flipped 5 times, how many possible outcomes are there? Well, that's 2 to the 5th power, which gives us 32. If a coin is flipped 5 times, how many possible outcomes are there that involves exactly one head? So that's going to be 5 combination 1. Of those 5 coin flips, I want only one of them to be heads. And that calculates to a 5. Alright, number 18, we have a family of 9, and we're breaking it up into groups. So we've got a parent group that has 2. We have a daughter group that has 3. We have a son group that has 3. And we have a cousin group that has 1. And it says, how many ways can family photos be created by choosing 2 from the parent group, 2 from the daughter group, 1 from the son group, and 1 from the cousin group? So from the parents, we have 2 of those, and we want to choose both of them. From the daughter group, we have 3, and we want to choose 2 of those. From the son group, we have 3 of those, and we want to choose 1 of them. And then from the cousin group, we have 1 of them, and we want to choose 1. So 2 combination 2 times 3 combination 2 times 3 combination 1 times 1 combination 1, and that calculates to a 9. Alright, number 19, the most popular options for hamburgers are mustard, ketchup, onions, pickles, lettuce, tomato, cheese, and mayonnaise. How many different hamburgers can be ordered? So we've got 1, 2, 3, 4, 5, 6, 7, 8 items in my set. So that's going to be 2 to the 8th possible hamburgers, which is 256. Alright, Fred is going to have a dinner party, and he's limited to 10 guests. He has 20 friends that are Democrat and 10 friends that are Republican. How many ways can he choose 10 out of 30 friends? So that's going to be 30 combination 10. So 30 combination 10. That ends up giving us 300,45015, or about 30,045,015. Alright, Fred is having a dinner party and is limited to 10 guests. He has 20 friends that are Democrat and 10 friends that are Republican. We want to find out how many ways he can choose 10 from the Democrat group and 0 from the Republican group. So we've got 20 Democrats, 10 Republicans. We want to choose 10 from the Democrat group and 0 from the Republican group. So that is going to be 20 combination 10 times 10 combination 0. And that's going to calculate to 184,756. All right, the next one. Well, this time Fred, he's going to choose 5 Democrats and 5 Republicans. So here's our Democrat group. Here's our Republican group. So we're going to be choosing 5 from each group. So that's going to be 20 combination 5 times 10 combination 5. So 20 combination 5 times 10, 10 combination 5. And that ends up giving us 390,708. So there's about 3,907,008 ways to do that. Alright, and the last one here. Brad's having a dinner party. He's going to choose 10 Republicans and 0 Democrats. So here's our Democrats. We've got 20 of those. Here's our Republicans. We've got 10 of those. So we're choosing 0 from the Democrat group, 10 from the Republican group. So it's going to be 20 combination 0 times 10 combination 10, and that ends up calculating to 1.